This is the capstone presentation by Daniel Santana and Nate Gully.
The problem we're trying to solve with this egg incubator is if someone wanted to have a egg incubator in this specific case, or like a fish tank or some sort of environment, and have it be automatically maintain like a certain temperature and humidity, kind of like a thermostat, and you want to be able to check up on it or like share with other people, you could use this same process. The egg incubator should allow you to maintain an environment without with this little direct intervention as possible. You should get notes and or updates if anything goes wrong. And you can also, share with your friends without having to have them come over to your house, which is perfect for this whole coronavirus thing because social distance thing, because you can show you what you want to maintain without worrying about them coming over or whatever. When you can let people in to see it, you can kind of just send them like a link.
So the overall architecture for our hardware is a styrofoam cooler, two heating pads, two temperature sensors and humidity sensors, and a parasolic pump and a fan, the Arduino, and the LCD screen. The temperature sensors that were used were the DHT22 and the DHT11.
Okay, so for the software architecture side of this website or this project, I would consider the website being one section of the one thing that one component of the software architecture. I would also consider the front end, which is built in React JavaScript. The back end is going to be the API section of the website, and that's basically going to be just like the back section of the website. It's going to be this backbones and this API folder. The another section is going to be the SQL database that the Raspberry Pi would be hosting, and then those three things are going to make up most of the components to build the overall architecture of the project as we have it configured currently.
Okay, so more in depth look about what it would actually some of these more specific sections are. We can talk about like what some of the level one requirements are. So to kick us off, I'll start with like kind of like this is explaining the website. So this is kind of like the website. This is what I built. I built in Visual Studio Code. It's made up of React, which is a JavaScript library. I used Bulma.io to format like the CSS sense of it. So let's kind of have like the layout of it. I use some npm packages to connect to like the database. On the right side, this is going to be the app.js file. This is part of the backend for the API. So this is going to be how the website's going to be interacting with other programs. Essentially, so this is how it gets things from like the SQL database. This is where it gets information to connect to the SQL database. Um, and yeah, so essentially, we're gonna have like this is basically the layout. Well, this is actual bare bones code of like kind of what the website does. And let's just say like let's say like if you want to get the Pi to host the website locally, you're gonna run npm run start dev, which is gonna go into this package.json file. It's gonna run this script, and when it runs this script, first of all, explain it. So concurrently is basically what lets me run more than one lets me do more than one script at one time. It's part of a Node.js application, which is another JavaScript library that lets me run and create actual servers. So it's going to start the front end, and then it's also going to do the back end, and that's going to allow me to talk to the database, and then actually put things on the website. And to get the current target information, it's going to be going right here. Okay, it's going to run these get current and get target data. and it's going to be running a fetch and going through the backend, making a request on this backend, and it's going to go from it's going to run SQL queries and it's going to send the results back to the front end, and then it's going to put it into an array, and then it's going to put the information from the array into the actual and set that as a current state for the website. It's going to do it every time you load this website. So every time this component mounts, it's going to run those functions and get the current information. And one of the reasons we put it in the SQL database is because that way you can not only would you be able to keep track of like what each current and target temperature are, or each current and target temperature is at each event storage, which I can get more into later when I talk about how the SQL database is formatted, is you can have those tables be really long and it'll always pull the most current one. One of the requirements I forgot to mention is the fact that the website should have different levels of access, basically. So like you can have an owner level access where you'd be able to do more things and interact with the pie and set more variables. Whereas you could have a guest level access where you can share with your friends and they wouldn't be able to directly interact with whatever. Like they wouldn't be able to direct the variables or directly change anything in your project, but they would still be able to view it and see your progress. Okay, so another one of the level one requirements we wanted to have the SQL database, and this is going to be like the SQL code, how we create all the tables. And basically, we're gonna have like let's see, 5 tables. And okay, so there's gonna be owner ID, so that's where you get like you store the contact information, the contact email for whoever owns the setup. The main egg table is going to be connected to the owner ID table based on the owner ID. Your egg events table is going to store all the events for each individual that happens in each individual egg story, quote unquote, is what I'm gonna call it. And each egg, you can track each egg story, and that's by the egg type and the trial ID in the egg main table. The current info and target info are going to be 2 other tables and that's going to be what the website's going to be pulling from to get the current and target information. And the reason that I said earlier is it's a good thing to have them stored in the database and not really have a limit on them is because at each individual event storage, you can also tell what the current and target information for those. You can tell what the current and target information for that was set at that actual time when that event was stored, whether it be like a level 1 event when it's just that could just be like a routine data storage, it could be a level 2 event where like something happened but you don't need a direct intervention, or you could have a level 3 event where it would require like someone to come actually go and physically interact with the egg incubator and actually fix something. So it could be like a power outage, so you need to go check on the eggs, or it could be or it could be that it got too hot, or the Arduino can't, or it could be that the Arduino isn't storing information or hasn't stored anything in the past, however long, or that the Raspberry Pi hasn't, or that the Arduino lost connection to the Raspberry Pi for days, or just anything that could be a level 3 event. That just means that it's more major, and these are all tied. These are connected to the egg events table by the egg event ID and egg event date.
This is a quick overview of all the hardware requirements that we laid out during our specifications document and our design document. Level 1s, as we see here, are those that are mandatory in what the device should have. Level 2 are ones that we could implement. Level 3 are those that we wish we could implement if we had more time. All of the hardware requirements level 1 are completed. The ones level 3 that were completed are the Arduino will require the temperature sensor to read the temperature in a decimal format to the hundredths place. For example, 75.53, 75.63. The other one that was completed was the Arduino will require the humidity sensor to read the humidity to the hundredth place, like the temperature sensor, but in a percentage, 50.64%.
It's a little more in-depth demo to like what the website is and how it's going to be working. Um, so okay, so I'll get even more in depth, more specific. Is going to so the current temperature and target temperature is going to be pulled directly from the database, and it's being pulled in these functions right here. There's get contact info, or not get contact info. It's going to be get current data and set get target data and get current data right here. It's also going to be connecting to the database right here, and this is going to be in one of the backends of the application. Um, in the backend of the full application, this is kind of the overall file structure. This isn't Visual Studio Code, so it's actually showing like, so this is what I used to build the website. So essentially, this is going to be the file structure. I'm trying to use a laptop mouse, which is not going very good. And yeah, so in this API folder is going to be everything in the backend. That's how the website communicates with, makes calls to SQL database to get the information. That's how, and that's how this is what everyone who would log in would see. This is the front end part, and basically it should automatically pull information from the database and put it in here. And this tells you kind of like what level the users are. Right now it's supposed to be set to be the owner. And basically, and another thing, let's see the database, and okay, this is the backend of the database, and this is kind of like where things are going to be stored and information. But I can get more into that also in a little bit. But essentially, so far all you really do is kind of load up this page and kind of see the information, and everything else should be done in the backend.
So this is the overall connections. This USB cable connects to the Raspberry Pi. Arduino connects to every component that's here. The pressure lock pump, the LCD screen, and then temperature sensors that are inside here. And then there's a fan inside that helps with airflow. There's a sponge to help soak in the water. Heating pad, 2 of them. One of the temperature sensors, one of the other temperature sensors. Fan's just below this styrofoam lid. And then all the wires connected to help with the power for the heating pad and the fan and the pump, so that it doesn't short the Arduino. As you can see that the Arduino constantly reads the temperature at a constant pace, but as we will see in a second on the serial communication, that it updates to the serial port to the Arduino, to the Raspberry Pi every 5 seconds. So this little node script I wrote just to prove the serial communication between the Raspberry Pi and the Arduino. Actually, I forgot. It's the serial port updates every 2 seconds, while on the LCD screen it updates constantly. This runs the API and the website to start it. See it connected, and then it's starting the server, and then web page pops up, and then it shows up onto here what the current temperature is. As you can see, the serial port shows around what it is. 186. and then target humidity and all that.
Okay, so as you can see in the background, this is the website for our egg incubator, and this is one of the level one requirements that we were able to finish what we wanted to do. Having it basically creating a website, the Raspberry Pi should be able to host for the user to interact with, control their Arduino with, and set their environment up with. Um, so this is gonna be this is the background, like the website for it. There's also going to be a SQL database for it, and then on top of that, it's gonna be the actual code for the website, and it's gonna connect to a backend, which I'll get more into later. And some of the requirements that we wanted to do is we wanted to make sure that Arduino could balance and maintain a temperature, and the Raspberry Pi would be able to communicate with each other through serial communication. So one of the level one requirements I'm sure you've seen because I've been flipping through all the screens, but I didn't get to finish yet. Was the email feature, and I started it. A lot of this big commented out code is, but this is actually another part of it. But basically, having the website be able to send an email paid with an event was I was not able to get it working. Because first I tried to get like the text message part with Nextmail, which is right here, take it out, and Twilo, which I believe is right here. And yeah, that's the Twilo part. And but first of all, both of those cost money, so I didn't have money necessarily to be paying for that. And on top of that, so I tried to use the email feature part, but then the email feature part was not working properly. So I didn't as of right now I didn't finish it yet. I'm still working on it. And basically, I couldn't like one of the main reasons I believe not being able to get it done is because during this whole, as everyone knows, this whole COVID-19 thing happened. So I did not have time, and I lost one extra week after spring break. My laptop broke, and then and then after I was in quarantine when I was able to come back here to campus. This is where my campus in Chum would be. And then after that, I lost some more time and had to recover all the data from my laptop. So by the time I got everything that got try to get some more of these features running, I ran into a bunch of errors. So it was if I had at least like one more week or even like a few more days, I might be able to get some flush out some of these features and get them working properly. But as of right now, I couldn't. Yeah, there's so many things happening. So yeah, but that's why we couldn't do one of the level one requirements, and I believe that's the only one that we didn't do.
So this is my Arduino code file that I wrote up for controlling all of the mechanical components for the project. We got the LCD screen, two DHT sensors, two different types. It was one type, but couldn't find the second pairing of the DHT22s. But fortunately enough, I had a DHT11 that I could use. Then we got the peristaltic pump, the fan pin, which is just says either on or off. There's no really controlling it, really. It's mostly just there for just airflow. Then heating pads. There's only one instance of it since I'm treating it as one unit, so that whenever the heat gets too high, both of them will shut off or heating, lower the heat. As we can see right here in this function, that in this case, if the average temperature, which is taking the two DHT sensors readings and then averaging them out, if that average is greater than 110 degrees Fahrenheit, it will shut it off or send out a signal, an analog signal, to shut it off, and then just as proof of concept to say the heat is off in the serial port. And then if the average temp is lower than the temperature minimum, which is 75.5, just an arbitrary number right now, it will crank up the heating pads to its maximum capacity, and then the rest of them are in betweens. As for the fan, it reads the average temperature, takes in the average temperature and compares it to the minimum, which was 75.5. And if that average temperature goes below that, it will shut off the fan because that is the air circulating unit and will allow it to uh, keep heating. And then, if else, it's always on. Peristaltic pump takes in a reading of humidity. In this case, it takes the sensor that was closest to it and then compares it to a minimum value. And it sends out a signal. The humidity is less than min. It will turn on the pump at full, and then if else, the peristaltic pump will be shut off. As just for displaying some of the data, this is just for serial port communication between Arduino and the Raspberry Pi. And this shows the sensor data, so of the two. So as you see here, average temp is calculated here, where the converted, which is because these sensors read in Celsius by default. So doing the calculation to convert it to Fahrenheit, and then taking those converted values, and then adding them together and averaging them out to get the average temp, so that this value is used to compare to allow all these to function. And then this is just the loop with the all of these functions that are created. One thing that didn't really get done was an actual menu, but I do have a button that works, and whenever it reads that it's being pressed, it will count, and if that count is over 1,000, which is equal to about a second, it will change the LCD screen and print out different um, different screens. So this one is just for the first sensor, and then anything in between second, after a second and 2 seconds, it will be temperature, the second temperature reading, the second humidity reading, and then the last one, if anything above two count of 2,000, it will show the average temp and then what the temp min is. Probably only reason why that didn't get done, having a full like 3 or 4 button menu, is because I did not have enough resistors to accommodate all those. I had enough resistors to use for one, and then add for the used for the heating pads and the peristaltic pump and the fan. So I didn't have enough to create a full menu. If I did have those components, I would have made a simple menu to show the proof of concept. One thing that needs to be mentioned is the menu was a level 1 requirement, and I explained how that was completed. Then also the actual reading of the temperature and the humidity separately of the two sensors and displaying them. That was a level 3 requirement that we came up with. Besides the menu, all the level 1 requirements for the hardware side have been completed.
Okay, so when it came to like actually implementing this, I would say one thing that was majorly different in terms of what we actually like planned for and what actually happened would have been this. Like this is our design document, and we originally had these tables laid out. Um, didn't have a login database table because it doesn't make sense for store passwords or these kind of things in there. It would be better to just have like a package handle everything. Even though we didn't get to it, this is how I would have organized it. A lot of the features that when we actually got down to it, a lot of the features that we wanted to implement, we didn't get to do because of the time factor and because of the whole COVID-19, all the hangups we ran into. But I would definitely say one thing we definitely changed would have been how I organized this SQL table, because when it came to linking things, I wasn't able to link things the way I originally planned, and I can get rid of some redundant things and hopefully try to make this thing smaller. I did end up still creating the same amount of tables, same 5 tables, but it's still um, changed a little bit. Another aspect I probably would have changed about this would have been the user interface side, because rather than having all these buttons laid out like this, I'd probably want to have it all laid out that way the user doesn't have to go search for anything. So I think it'd make more sense and it'd be more convenient for the user. Um, and then we also didn't get to doing this, but I still just laid all this information out instead of having the user go digging for it from user interface standpoint. And yeah, that's like those are two big changes that I realized when we went to go implement was a lot harder than we actually planned. So we had to change some things up.
Okay, if I could go back and change how I laid out some of these things for like planning, I'd probably redo how I organize this UI user interface because and I might make it a little more make it look a little different because I know this may not look the most exciting website, but I'd probably make it a little more flushed. I don't know. I'd probably just make organize it a little more. I'd probably be able to if I had more. I definitely hope I have more time and I can actually get this page to look a lot better than I guess I think it does. Um, and I think I'd also probably work on. I'd probably maybe make it, yeah, like I said, like a little bit more smaller. I'd probably add some security verification that way I can actually, uh, that way I probably have more time to do it because I did want to do it for this project, but I wouldn't have time, like I said before. But I'd probably maybe have some sort of logging feature, create like a pop-up modal, which is like a little menu that would pop up and be grayed out, so it should block. So it would block or allow access depending on if you enter the right password in, if you're the owner, or if you have the right link, if you're coming in correctly. And then I'd probably like I said, obviously I said I definitely would try to work a little more on how to get the email function working more efficiently and working as it is because it's not really working yet, but it might be. I'm still gonna work on it.
The hardware design hasn't changed drastically at all. The only changes were just placement of the components around the enclosed area. One thing that did change when putting this together was that one of my um temperature sensors and humidity um, sensors were not where it was supposed to be. Um, Misplaced, left it. I have no idea. But luckily enough, I had an extra uh, one different type. The one that were going to be originally used were two of the DHT 22s, but replaced one of them with the Humiture sensor, it's called, by Sunfounder. and that is an equivalent to a DHT11. So a little slower in the response speed and reading the temperatures and the humidity. But that wasn't a problem in implementing and how the serial port reads it, because the serial port reads it on its own in its own time frame.
Okay, so some of the challenges that I ran into when I was doing this project is, well, I'll start from the thing. Other than that whole COVID thing, I lost about a month of work time because I had to recover my project. I was not really in a place because I had moved around, and it was really hard to get this project together and working. And on top of that, Dan and I are on opposite sides of the country now because Dan had to go home, or Dan went home to California. I'm in Vermont still, so I'm working on the website part, and he has all the hardware, so like the Arduino and the Raspberry Pi. So it's very hard for us to, get this whole project integrated, especially with me not being in like the same place and me being moving around, being in quarantine, not having access to my laptop. It was very difficult. Another challenge that was really hard is after I was able to recover my files, I like when I first pulled up my website or pulled the file into my desktop, and there were a bunch of vulnerabilities and package collisions that just weren't that I had to fix before I can get this whole project back up and running. Because if you don't update your package, it's a lot easier to maintain like a project if you run it every day, check the packages, patch the packages as they come in. I can add and remove packages, if there are conflicts, change them out, but it's lost about let's say like 3 or 4 weeks. Then after I loaded everything up again with all those updates, how that they could all roll out and they could kind of cause collisions. I didn't really have time, and so I had 50 or something or 300 something collisions. It was pretty frustrating, so I had to iron those things out before I can get it working. And then I also had to reset up the database, which was kind of difficult, but I did. And make sure all the API and stuff was pulling from it all over again. And the challenge I had is actually recording this because I don't have a webcam on my computer, so I was using a loaner laptop, and then I messed up the loaner laptop because I dropped it, and then it wouldn't work. So here I am using another computer to record this. I'm sorry if it's not as concise or clean as it could be. There have been so many hiccups, and but I'm still trying. So I'm trying to get this thing in and finished. So here it is. And then some of the challenges we ran into is this whole like email messaging things. I didn't know it would cost money. I didn't think it would cost money. So, but then when I tried to use the email feature, it was very hard for me to be able to pass data into the back end because let's see if I can show you the specific line. But it was really frustrating because okay, so this is the function that I was going to try to use to send this email, and the part that was really not working is right here. Okay, this is where it would create the message, which fine, but okay, so it was right here. This whole logic is how it should be built in the message to send, and right here, I can go to the back end and I can pull the information, and it'll tell me like what my contact email and phone number is. But then like literally the next line, like right after this line right here, right after this line, everything looks blank. So then it says that it's null, and I still want to keep looking into it, see if I can figure out why it says it's empty. But that was another roadblock that I really felt was really frustrating because I couldn't. It doesn't make sense to me that why it's empty because it shouldn't be empty. So that's another challenge that we faced, and I know it's been a wild ride, but like you gotta push through it so you get things done. So yeah, those are some of the challenges that we ran into when creating this egg incubator.
Challenges that occurred while creating this CapStone project were some software challenges, like having the Arduino IDE crash at very inconvenient times while writing the code. For example, I would write some code for the parasolic bomb to make sure that it's checking that the humidity is at a optimal um, percentage, and if it goes over, it shuts off completely and doesn't keep going. But there, but then that inconvenience would happen, and then I would lose all that code. Other things for the Arduino um, was the IDE itself, making sure that it's updated, all that. The sketch would sometimes break in the sense that I would write code, save it, it's fine, but for some reason it would not upload to the Arduino. So I would have to copy and paste to a different sketch and then see if it uploads. And if it did, it was good. And all every time it was just I had to put it on a new sketch page. The other thing was finding a database server, an SQL server. At first, Nate and I wanted to use MySQL because we were very familiar with the GUI and the IDE, and we wanted to download it onto the Pi. But unfortunately, it was not compatible. The GUI nor installing the package, the SQL server, through sudo, which was unfortunate because we wanted to use that because we're very familiar. But after that failed attempt of installation, the terminal gave us a recommendation saying that to use MariaDB, and so we installed it. It worked. Runs like MySQL, but except it doesn't have the GUI. It's all shell based. So trying to learn the shell and doing everything through the shell was a bit of a learning curve, but got through it. Wasn't hard. Just had to remember a few commands to easily navigate through it. And that was the hardest part, trying to create the database first and the schema, and then making sure that all the tables are created and all that. And then hardware wise, just trying to make sure not to short anything, because that was the big thing back on campus before we got sent back. Shorted a Arduino, and I guess it got too much power and it shorted it, and then caused damage to my laptop itself, creating an unusable USB port, and actually shut off my laptop. And I was kind of scared at first because I thought my laptop was toast, but fortunately enough, it's just the USB hub. Getting all the components and parts, wires, sensors, and then any little thing that tools that I would probably need. I have to put it in the box and then have it get shipped back to my home in California, which was a bit of a hassle in itself because it caused some delays because I shipped it and then it didn't get shipped when it was supposed to or delivered when it was supposed to. So I had to wait a while before I could start back working on it. And then having enough wire and parts to fully utilize the space given to me by the styrofoam cooler. Because originally, testing wise, just having everything close together with 6 inches of cable to make sure that everything works first, but didn't really think about, oh, I need some extra cable to bring with me and ship back home so that I can extend it, especially for the heating pads, because one of the heating pads would need to be on the bottom of the styrofoam cooler, and the other one near the middle or closer to the top of the styrofoam cooler. And then same thing with the temperature in a position where it's not fully affected by the heating pads, so it doesn't cause a error in reading the temperature. So trying to utilize as much space and then trying to get everything in the correct places so that both of the sensors could read the temperature correctly and not be overly influenced by the heating pads. And then another was a missing DHT22 temperature humidity sensor because that somehow one of them gone missing. Or originally we were going to use two DHT22s, but somehow one of them got lost in the process of shipment or me grabbing it from the STEM basement where we were working on it and then putting it in the box. So it could have been my fault. It could have fallen out of the box. That might have happened. It might have not. But luckily enough, had a spare sensor that I brought just in case one of them ended up blowing, shorting out. So it all worked in the end. Being remote was probably the most challenging because we couldn't really fully utilize testing, and then communication wise, me being back in Cal, 3 hours behind, um, where Nate's back on campus. So me working on the project at like midnight, and he would probably be asleep because it's three three in the morning for him. So trying to find a time to meet together and then all that. But we figured it out, got through it.
Okay, in terms of what I've learned is that like I've definitely gotten better at how to learn how to create an API, which is the backend for this website, which I've always wanted to do. And kind of integrate. I've learned how to pass information from the front end to the back end because I've done it. I've done it with a bunch of with other parts of this project, but I just couldn't do it with this email. So I got to figure out why that's not working. I learned how to integrate a website with a SQL database, and that was also really interesting for me because I really always wanted to know how to make that and build that connection. I also used Bulma.io, which is a CSS library. It's gonna be right here. And this is what we use to actually format the website and use colors, etc. I use React JavaScript, which is a JavaScript library that I got more proficient at after while building this website. Um, I found out that they have this cool color palette things, but I pulled the colors from for the website, which is pretty cool. And I don't know, just really good. I think I learned a lot about coding and like even I basically learned that like I knew that when you plan out a project, obviously as you code it's gonna be different, but I guess going away from a project for 3 weeks and coming back to it, having everything be not broken, but not work, just basically broken. That's kind of how it was. So and like that, I kind of learned that like if you're gonna build a project, it's really good to keep checking up on it, even if you're not gonna work on it every day. It's still good to get into the project, make sure everything's still working, and you can update everything increment in increments rather than just updating things after a month when you haven't touched it and everything just breaks and falls apart. So it's good to just keep checking in with your projects every now and then.
Biggest lesson I learned was that the key to a team project, is the communication between its members. And with that, getting everything, all the components, all the software, hardware, all of it together and work. Though that was quite difficult since he and I are on other sides of the country. I'm back in the West Coast. He's still in Vermont. Learned a lot of new things about using the Arduino and microcontroller, and using the Raspberry Pi, which I was not familiar with. So that was a good experience. And then trying to utilize a website to incorporate everything. CapStone, I feel like, was an excellent, good experience and challenging, since it kind of shows us what's going to happen when we go to work for a company that requires some projects to be done in teams.
So many comments. Let's see. Honestly, building this project is like with most projects, not as straightforward as I'd like it to be, but it was still pretty. It was still really fun. I like the challenge aspect of it. Now I have the skills I wanted to build basically build a self-sustaining environment that I can check in and monitor through the internet. So for example, like I've always wanted to build a fish tank system that could be maintain temperature and like obviously not humidity because it's underwater. But, like have it feed automatically every now and then, make sure the fish tank or the filter's always on, turn a light and show the webcam so I can see inside the fish tank when I'm not home. Like be able to build the whole system, and I can do that with essentially the same concepts that I've learned and built through the same this project, and I can do it for free or for really really cheap because I learned how to code everything myself. So that's really cool. And I'd also really want to apply the same concept of building this kind of project to like manage eventually a home, so I could build my own smart home management system slash monitoring system, which would be really cool. And I think that you could also apply the same concept to like to almost just about anything. You can use to apply like a thermostat and create, I guess, a smart home through, with an Arduino or Raspberry Pi. And or you I mean you could probably even put it in a car. And I don't know if you'd want to like maintain like a temperature instead of a car. I guess you could, but I don't know. You could just use it to maintain any sort of stable environment when you can't directly be there. And like I said in the previous section, they also need to keep up with your projects. Make sure you constantly are checking back in, bringing it up to date. Also, it's always good to have a backup because because one laptop messed up and then I messed up the other laptop. So maybe I'll start putting things in the cloud because that seems like the thing to do. So honestly, if I had to do this project again, I would definitely start storing things in the cloud. But it was still really fun, so I definitely want to build something just like this in the future. And thank you for coming to my capstone. Well, not my capstone, our capstone.
Final thoughts on this overall capstone experience was that it was a good and challenging experience, to say the least, especially during these times. I can use the knowledge I've gathered in completing this project to further my own dreams and goals in programming. One other thing that I learned was that you probably should always have a backup plan for your backup, just in case something unexpected happens. Just like how we were sent home and then things got lost and all that. So that is the conclusion of the capstone video presentation. Thank you for watching.